Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul uqdatam min lisani yafqahu qawli. Assalamu alaikum. Today we are going to learn combining displacements. Combining displacement. The walkers shown in figure 1.12 are crossing difficult ground. They navigate from one prominent point to the next, traveling in a series of straight lines. From map, they can work out the distance as they travel and their displacement from their starting point. Distance traveled is equal to 25 km. Lay thread along the route on map. Measure thread against map scale. Displacement is equal to 15 km northeast. Join starting and finishing points with straight line. Measure line against scale. If we look at the map, we see that the walkers travel in haphazard direction, giving a total distance of 25 km. If we draw a straight line from start to finish, it is equal to 15 km in northeast direction, and that will be our displacement. A map is a scale drawing. You can find your displacement by measuring the map. But how can you calculate your displacement? You need to use ideas from geometry and trigonometry. Worked examples 3 and 4 show how. Worked example 3. A spider runs along two sides of a table. Figure 1.13. Calculate its final displacement. Figure 1.13. The spider runs a distance of 2 meters, but what is its displacement? If we look at the table, the spider travels from 0 to point A in north direction, which is equal to 0.8 meter, and then from A to B, which is equal to 1.2 meter in east direction, giving the total distance of 1.2 meter plus 0.8 meter is equal to 2 meter. We need to calculate displacement, which is the line connecting from the origin to point P. Because the two sections of the spider run OA and OAB are at right angles, we can add the two displacement using Pythagoras Theorem. OB square is equal to OA square plus AB square, which is equal to 0.8 square plus 1.2 square, which is equal to 2.08. OB is equal to under root 2.08, which is equal to 1.44 meter or approximately 1.4 meter. If we look at the figure, we see that it forms a right angle triangle. The distance between origin and A is 0.8 meter, and from A to B it is 1.2 meter. We need to find the length of O and B. We will apply the Pythagoras theorem, which is OB square is equal to 0.8 square plus 1.2 square, and from that we get OB is equal to 1.4 meters. Step 2. Displacement is a vector. We have found the magnitude of this vector, but now we need to find its direction. The angle theta is given by tan theta is equal to opposite over adjacent. We can see from the figure that the opposite side is equal to 0.8 meter and the adjacent side is equal to 1.2 meter. Therefore, tan theta is equal to 0.8 over 1.2, which is equal to 0.667. Theta is equal to tan inverse of 0.667, which is equal to 33.7 degree or 34 degree. So the spider's displacement is 1.4 meter at an angle of 34 degree north of east. Worked example 4. An aircraft flies 30 km due east and then 50 km northeast, figure 1.14. Calculate the final displacement of the aircraft. Figure 1.14. What is the aircraft's final displacement? It travels 30 km east and then 50 km northeast. Here the two displacements are not at 90 degree to one another, so we cannot use Pythagoras theorem. We can solve this problem by making a scale drawing and measuring the final displacement. However, you could solve the same problem using trigonometry. Step 1. Choose a suitable scale. Your diagram should be reasonably large. In this case, a scale of 1 centimeter to represent 5 km is reasonable. Step 2. Draw a line to represent the first vector. North is at the top of the page. The line is 6 centimeter long towards the east. Right. If we look at the graph, north represents top of the page, south represents toward the bottom of the page, east is to the right, and west is to the left. The first thing that the aeroplane travels is 30 kilometer due east. So if 1 centimeter represents 5 kilometer, this means that we will draw a 6 centimeter line towards the east. And then at a 45 degree, we need to represent 50 kilometer, which would be equal to 10 centimeter, as 1 centimeter is equal to 5 kilometer, and we'll draw the second line. Step 3. Draw the line to represent the second vector starting at the end of the first vector. The line is 10 centimeter long and at an angle of 45 degree, figure 1.15. Figure 1.15, scale drawing for work example 4 using graph paper can help you to show the vectors in the correct directions. Step 4. To find the final displacement, join the start to the finish. You have created a vector triangle. Measure this displacement vector and use the scale to convert back to kilometers. Length of vector is equal to 14.8 centimeter. Final displacement is equal to 14.8 into 5, which is equal to 74 kilometer. Step 5. Measure the angle of the final displacement vector. Angle is equal to 28 degree north of east. Therefore, the aircraft's final displacement is 74 kilometer at 28 degree north of east. The final displacement is the line joining the initial point to the final point. The length is measured on the graph paper is equal to 14.8 centimeter. Since 1 centimeter represents 5 kilometer, the final displacement would be equal to 14.8 centimeter into 5, which is equal to 74 kilometer. The angle between the final displacement and east is equal to 28 degree. Therefore, the final displacement is 74 kilometer at 28 degree north of east. Thank you for watching. Allah Hafiz.